Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at how to simplify a rational expression. So let's go ahead and begin. Now, the first thing we have to do is we have to make sure we understand what exactly a rational expression is. So to put it simply, a rational expression is whenever you have a numerator over a denominator, or another word for that would be a fraction. So P over Q would be an example of a rational expression. And the caveat is, and I don't think this is critical, but the caveat is that Q cannot equal 0. If Q equals 0, in this particular situation, it would be undefined. And so, again, we're looking at how to simplify a rational expression. Now, we know what a rational expression is, but they're normally more complicated than P over Q. An expression often involves several terms, often, like a quadratic expression or something like that. And that's what we're going to really focus on in this particular video. Doing this is not that complicated if you're familiar with how to factor and the different methods of factoring, and then how to address simplifying a rational expression or fraction, if you will. So let's take a look at that. Let's say that I have the following rational expression: x squared minus x minus 2 over x squared minus 3x plus 2. Now, in order to have success for this, what I have to do is I have to first factor the top. You can do the bottom. The order doesn't matter. It doesn't matter. Factor the bottom, and then I can figure out how to simplify it. So, now that I've done that, why don't we go ahead and deal with the top first? So I want to factor this. Now, remember, we have the grouping method, the AC method. Let's just take a look at that. If I want to factor this is what I know. The first thing you do, of course, if I'm doing the AC method, is I have to take x. This is 1 here. This it's x, so it's 1. 1 times negative 2. So is my a dot c is going to equal negative 2. So when I'm trying to figure out what the factor is going to be, when I multiply these two terms that are going to be my factor, they must come up, the product must be negative 2. And of course, then we have our b term in the middle. Our b term in this case is going to be negative 1, because negative x is negative 1x. We don't put the 1 there because there's no point. Now, here's the thing. When I guess the better way to put that is, when I add my two factor terms, so a plus c, if you want to do it like that, is going to equal negative 1. That's probably a little bit clearer. Okay, it's going to equal my b term, if you will. So we got to try to figure out, okay, what values are going to work in this particular situation, where when I multiply it, it comes out to negative 2, and when I add them together, it comes out to negative 1. And I mean, this is not that deep. We don't have to, show work for this, but basically negative 2 and positive 1 will be my two answers, because negative 2 times positive 1 will be negative 2, and negative 2 plus 1 will be negative 1. So that's what it's going to work out to. So if I had to draw that, it will look something like this. I would have, let me give you a different color here. I would have x squared, when I break it apart, x squared minus 2x plus x minus 2. And so we will group these two together like so, and group this one over here with this one. And so when I bring it down, it'll be like the following. It'll be a negative 2 on the outside, x plus 1, like so. And then when I deal with this guy right here, I already showed you this one, I will put an x on the outside like so. Then I'll have my x on the inside plus 1. That's what I have. And so when I finally finish this all off, I will have x minus 2 as one of my terms, and x plus 1. That takes care of the top, the numerator, if you will. So I'm going to go ahead and put that up here. So we're going to have x minus 2, x plus 1. That's our top number right there. Okay, now why don't we go ahead and deal with our denominator. So we're looking at this right here. X squared minus 3x plus 2. X squared minus 3x plus 2. And so again, I go through the same AC method. A times C is going to be, looks like positive 2 this time. And then when I add A plus C, it should equal negative 3, because negative 3 is the B term here. So, I wonder what's going to work this time. Well, if I take negative 2 times negative 1, I will get positive 2. And if I take negative 2 plus negative 1, I will get negative 3. So it looks like negative 2, negative 1 will work if I want to break apart my B term here. So why don't I go ahead and try that? So now I have x squared minus, let's see here, 2x, and then minus x plus 2. And again, we do a similar approach here. We're going to group these 2's here, and then we're going to group this x over here. So if I deal with the negative 2x, I'll put the negative 2 on the outside. I'll have an x here. And then let's see here. For that particular one, I want a negative 1 because I want it to be a positive 2. So negative 2 times negative 1 will give me the positive 2 right here. That's what I want. And then over here, I'll have the x on the outside. Just to make this clear, I'm dealing with this one right here, this particular grouping. And then I'll have x on the inside, and then I'll have minus 1 again. That's what we'll have. So the final answer, or the final part for the factor at the bottom, is going to be, we're going to have x minus 2 because I'm combining these two right here. And then we're going to have x minus 1 like so. So let me go back and show you this. So x minus 2, x minus 1. So you can see, that's not clear, x minus 1, sorry. You can see here that we're almost done. Now we need to simplify. So as you know from dealing with fractions in the past, if you have the same number in the numerator or the same term in the numerator and also in the denominator, you can eliminate those, you can remove those. So if I look closely at this, I can see that I have x minus 2 in both the numerator and the denominator. So I can eliminate those, and then I'm left with the following. I'm left with x plus 1 in the numerator, and I'm left with x minus 1 in the denominator. And there's no way to further simplify this particular rational expression. And so essentially we're done. And so this is kind of how the process works for simplifying a rational expression. So let me go ahead and try to recap what we did here. First of all, we've had to try to figure out what a rational expression is. And it simply involves, a numerator and a denominator, p over q, with the assumption that q does not equal 0. Then we looked at how do we simplify a rational expression that has, quadratic terms or any kind of polynomial. And basically what you do is you use the grouping method, or you use some form of factoring. There's different ways that you're familiar with by now to try to factor the terms. And so once you have the factored terms, which again, I'm not going to repeat how to do that because we've discussed that in prior videos. Once you do that, you will have a factored numerator and you will have a factored denominator. If they share any common terms, you need to, of course, simplify them and remove those, and then you're left with your final answer, as you can see right here in this particular video. And so that's how you do it. So I hope this was practical and useful for you and that it made sense. I want to thank you for watching these videos. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.